which I'm going to have you guys work together on once I get you guys started. Okay, so the protractor postulate, it allows you guys to assign a value to an angle measure between 0 and 180. So basically using the protractor to come up with an angle measure where the values of the angles between 0 and 180 are valid measures of the angle. Okay, so what we're going to do with the protractor postulate is really that is used to prove some of the theorems that we have. However, you guys don't really need to know or use that. So I have that highlighted in one color, and you guys can even make a note. You don't need to know, except for it allows you guys to, like, I guess by know, I mean, you don't have to like memorize it or anything like that. It's just really to allow us to, that postulate allows us to assign a angle measure by a protractor. And so it's more of an application thing. All right, the next few you guys do have to know. So let's do that in a different color. Okay, angle addition postulate we've learned about. Supplements theorem is new, and complements theorem is new. Okay, so on the angle addition postulate, if you guys remember, let me call this angle 1 over here and angle 2 over here. And notice that angle 1 and angle 2 make up angle PQS. So angle addition postulate is really, really similar to segment addition postulate. It's just to say a piece being this angle plus another piece being this angle is the bigger angle at large. So here I'm going to say the measure of angle 1 plus the measure of angle 2 equals the measure of the larger angle PQS. And this is equivalent to or similar to your segment addition postulate. So it's still the idea of a piece plus a piece equals a whole, but it's in this case in reference to angles as opposed to segments. Okay, so moving on. So supplements theorem and complements theorem, that's going to be the ones that we're going to work on today. Okay, so let's say in the given part of your proof. In the given part, can you guys highlight that and write or underline it and write given? Okay, so if you're given that angle 1 and angle 2 are a linear pair, and we reviewed this the other day, right? The non-common sides are opposite rays, so it's a straight line for it to be a linear pair, 180 degrees together. We can assume that this is our statement after that. So let's say you were given that you can make the statement that measure of angle 1 is plus measure of angle 2 is equal to 180 degrees. And that is by, when we provide our reason would be supplements theorem. How do I know that? By supplements theorem. Okay, so again, let's say the highlighted part was given in a proof. It'll say given angle 1 and angle 2 form a linear pair. You guys would say, okay, what I can assume from that, my statement's going to be measure of angle 1 plus measure of angle 2 equals 180 degrees. And then my reason for that step would be supplements theorem. Okay, so it's kind of like an obvious thing that we already knew that relationship, but this allows us a justification when we're doing proofs with angles, with supplementary angles in that make up a linear pair. And so a similar one is complements theorem. Okay, so in the complements theorem, you guys would have to be given that two lines are perpendicular to each other. If they're perpendicular to each other, your conclusion, or immediately after you're given, your statement, your assertion is going to be that, for that to be E, your statement is going to be that the measure of angle 3 plus the measure of angle 4 equals 90 degrees. So similar in the sense that your statement here adds up to 180, this one's going to add up to 90. And the reason for that would be, I know this by complements theorem. Okay, so last year I went through these activities down here, but I feel like it didn't, we already know some of these relationships, and it helps for you guys to see proofs as opposed to just these exercises. So what I'd like to do instead is have you guys go to, let me see, oh, let me scroll without you guys seeing so that it doesn't give you a headache. Let me find that everything's in the packet, you guys, not the additional things that you printed. Let me find the, okay. So can you guys go now to page in the same packet, page 32 for me? Okay, and so I'm gonna just have you guys listen to me say this. When I was at Edison and we were using a different reference for theorems, because what a theorem is someone used the postulates before and things that they knew were true to prove certain things. So every theorem has a proof behind it so that you know, okay, the supplements theorem and the complements theorem are true because of these reasons. Now, one textbook might call it a linear pair theorem, and another textbook might call it a supplements theorem. That's one of the frustrating things about, I think, these proofs at the beginning of geometry. Whereas when we move into the parallel lines and the triangles, those are a little bit more standardized from textbook to textbook or source to source. The ones that I highlighted with you guys, the complements theorem and the supplements theorem, are going to be the ones that we use in this class. Okay, I found this nice proof. It's called linear, or these proofs. Because they are related to linear pair, this source refers to it as linear pair theorem. Okay, so I'm going to do a proof with you guys the way that I would like to see it in our class. And then if you guys have any questions about it, then let me know. I'm going to fix the key so it says the theorems that we're using in our textbook, and so that it matches and so it makes sense to you guys that way. Okay, so I know you see linear pair theorem. We call it the supplements theorem. Okay, so let's first start off with the given. Okay, on your statement 1, you guys are going to write angle 1 and angle 2 form a linear pair. Okay, and so similar to when I told you guys the tip of, hey, when you guys see midpoint, you're probably going to use definition of midpoint later. If you see linear pair, you're probably going to use supplements theorem at some point. So I'm listing out all my given. And what I'd like you guys to do, so you get familiar with what a linear pair is draw a straight line and then draw a ray that forms their common side and call one 1 and the other one 2. Okay, so angle 1 and angle 2 form a linear pair. You're also given that angle 1 is 30 degrees. So I mark off my picture. I go to step 2, and I'm going to use the fact that they mentioned this is a linear pair. And I'm going to say now that according to the supplements theorem, if you're given it's a linear pair, you're going to know the measure of angle 1 plus the measure of angle 2 must be equal to 180 degrees. And that's by supplements theorem, which you can abbreviate as SUPP and then THM for theorem. Okay, so here is where you guys, you should be able to take it from here. Okay, so given that you guys know angle 1 is 30 degrees, given that angle 1 is 30 degrees, and I'm trying to prove that angle 2 is 150, how might you guys use this information to come up with the third step? How might you guys use the fact that the measure of angle 1 is 30 degrees?
Substitution?
Yep, that's it. Like, so find 30 degrees, or measure of angle 1, plug 30 degrees in. Substitution. Property of equality. And then from there, you guys have 30 degrees plus measure of angle 2 equals 180. And we have to get to measure of angle 2 is equal to 150 degrees. How did I get there for step 4? What did I do to both sides?
Subtraction.
Subtraction. Perfect, thank you. Subtraction, property of equality. Good, you guys. All right, so now what I want you guys to, actually skip 2, and let's try
Can you go back up?
Yeah, you didn't finish copying? Are you guys good? We're still copying?
Thank you.
You're welcome. Okay, I'm trying to find one if they have any with complements. Let's talk about this right angle one. Okay, so on number 8, you guys, number 8 is on page 34. Okay, can I have you guys quietly write out your given and draw a picture for me? You guys want to make sure you draw a video of, and yes, I will post this video every time now going forward where I'm actually teaching a lesson with you guys. I post that video. I'm sorry, I know I trimmed the video and posted it on YouTube, but I don't know if I posted it on your agenda. I should have. I can't remember now if I did or not the last video. If not, today I will post both videos from the last time I saw you guys and then this time on your agenda for today. Okay, so that was just in response to a question on the chat. Yes, and Gavin, it's just because I think it's you're just kind of getting a little bit more used to it too. So DMK and KMB form a linear pair. Okay, DMK is a right angle. So I'm going to highlight this first and remind you guys that once you guys are given the linear pair, you should use that information in some way. Okay, so that means that I know the measure of angle DMK plus the measure of angle KMB must be equal to 180 degrees because of what we just learned, Supplements Theorem. Step 3, okay, step 3, I'm going to now use the other piece of information. This is new, sort of, and we're going to go over some of these other ones that you know but not really know, I guess, the formal reason. So let's say you're given that it's, I shouldn't have used the same color. Let me highlight this in a different color and then note that this is what I'm using it for. Okay, so angle DMK is a right angle. What do you guys know about right angles? If I asked you to define for me, what is a right angle? What would you guys say?
90-degree angle.
Exactly, so that's what you write here. Okay, you know that the measure of angle DMK is equal to 90. And notice that I said, can you guys define for me what a right angle is? So if you guys had to guess what the reason is, what do you think the reason might be?
Definition of a right angle.
Good, yeah, definition of right angle. So if it seems really basic to you, like that, well, that is what the definition is, then it's most likely a definition. So definition of right angle, and then keep going. Well, we have DMK in step 2, right here, we have DMK here, and we have DMK here. Okay, so DMK is 90, so I'm gonna plug 90 in, and I think you guys can do the rest, right? So we did substitution, prop here, and step 5 would be, I now know measure of angle KMB equals 90 degrees. Step 5 is, yep, subtraction property of equality. Okay, so I think your homework is from these few pages with the same types of proofs. And I will also post these on the solutions to these on line as well. So I have a few things I have to do with you guys. So if I can have you guys right now, it's the perfect timing. Let me scroll without giving you guys a headache. Let me scroll down to page 48 and 49, which we had done. I'm going to have you guys finish this up as classwork, but I want to do a few with you guys for you guys to get the hang of the angle ones. Okay, so angle day and angle yak are a linear pair. Number 5, angle day and angle yak are a linear pair. So that if that was the given, the conclusion again is your, oh, did I write? Oh, no, you need to do substitution. I can't remember what step 3 was. What was step 3, Richard? Oh yeah, you needed to do the swap. Thank you again. Okay, so angle day and angle yak are a linear pair. So if that was my given, my conclusion is really kind of like, what statement can I make? And then justification is, what reason can I provide? This is on page, towards the back of your same packet, page 48. Thank you. Okay, so my statement would be that I know the measure of angle day plus the measure of angle yak is equal to 180 degrees. You guys, what reason? Hopefully by now you know the reason. What's the reason for your conclusion?
Supplement theorem.
Supplements theorem. Good. Okay, I want you guys to compare and contrast that to number 6. Okay, so in number 5, you guys had this keyword that we've been using, linear pair, and we said if we see that, supplements theorem. On number 6, this says angle Thm is a supplement of angle Su. Okay, angle Thm is a supplement of angle Su. So that means that they're supplementary to each other. So the measure of angle Thm plus the measure of angle Su, if they're supplementary to each other, then I would know it's also equal to 180 degrees. Okay, notice that the statement that I made here is the same type of statement that I made in number 5, but I'm drawing this conclusion from not the fact that it was a linear pair, but because it was a supplement. And if I asked you guys to define for me what a supplement is, you would say it's the angle that adds to the other angle to be equal to 180 degrees. Okay, what do you guys think? Wild guess what the reason for 6 is. And it's not supplements theorem.
Definition of supplements?
Yeah, so definition of supplementary angles or supplements, either one is fine. That's it. Okay, so you always use what you're given, like the words in there, to give you guys a hint as to where to go with the justification. Okay, you guys, would you say that number 7, there's no words given, just a diagram. Would you guys say that that they form a linear pair, that those angles form a linear pair?
Yes.
Yes. Okay, so that again is your key word. From the diagram, you guys see that you're given a linear pair. So here we would say the measure of angle 5 plus the measure of angle 6. The statement I can make is that they add up to 180 degrees. Now, what do you think? Is this supplements theorem or is this definition of supplementary angles?
Theorem?
Sup
Because-
theorem.
Sup theorem.
Yeah.
Oh, that's kind of funny. Supplementary theorem or supplements theorem. Okay, so supplements theorem is the correct answer for that one because of the word linear pair, because the diagram is a linear pair. Now, let's try one with the right angles. Ooh, yeah, I like these two together, 8 and 10. So I'll do those two with you guys. Angle 8, or sorry, the angle in 8, the diagram, is clearly a right angle. Okay, so we haven't done too much with complements theorem, but like supplements theorem, if you guys are given 2 lines are perpendicular and they form a right angle, your conclusion on that diagram is that you know measure of angle 5 plus measure of angle 7 is equal to 90 degrees, similar to the way that we concluded with a linear pair that they add up to 180. So for a linear pair, you guys need a line with a ray coming from it. For complements theorem, you guys need a right angle. Okay, 2 lines form a right angle. So this is an example of complements theorem. I like to do this one back to back with number 10. Because if you guys look at number 10, can you tell me what the difference is between the diagram that you see in 8 and the diagram that you see in 10? And it's a...
There's no right angle square.
Okay, there is no right angle square. So do you guys think, what do you think I'll say when you say, well, it is a right angle? What do you think? Is that a right angle?
Do we use our protractor?
No, never use a protractor. Just go off of what the diagram is marked. What do you think? Would you say that so it looks like a right angle, but the writer is not telling you, the writer of the problem is not telling you that it is a right angle, so you can't make the assumption that it is, even if it might look like it. Okay, so then the question is, well, what else could I conclude? If that's all I'm given, it's not a right angle, there's nothing about perpendicular in there. You could conclude that just like the one above that a piece plus a piece is a whole for the segment. You can say this piece plus this piece is the whole thing, right? So that was measure, and let's see if you guys remember why. Measure of angle FEG plus the measure of angle DEG is equal to the measure of angle FEG. Okay, so what do you guys remember? What do you think that is? A piece plus a piece is a whole.
Addition angle postulate.
Yes, good. That's in there somewhere. Angle addition postulate. So similar to the one above that, segment addition postulate, this time you're adding a piece of an angle together makes the whole angle. It's angle addition postulate. Okay, and then below that, 11, we're just kind of cranking through these together because they're different. You're given that measure of angle ABC is equal to the measure of angle HIJ, and there's nothing else that's said about it. So the only thing I could conclude on this one is that angle ABC is congruent to angle HIJ. What do you guys think the reason is for that?
Definition of
Oh, good, yeah, of congruent. And Callie switched out the segments to now say angles. So it's almost the same one as the segments, but we're just paying mind to the fact that it's angle instead of segments. Okay, and then one that we're going to use so much after this chapter as well. Some of these we just really see it in this chapter a lot, but I'll say 12 is one that you guys are going to see over and over again. If you guys are given two angles are vertical, okay, your conclusion, what do you guys know about two angles that are vertical? What would you say your conclusion is? That they are, yeah, equal, that they're congruent. That measure of angle cats is equal to measure of angle wrap. And that is by vertical angles theorem, but because we use it so often, I'm fine with you guys saying VATS. It out for, stands for vertical angles theorem. Okay, I want to point out 14, and I think I'm going to let you guys try the other ones on your own. Okay, so 14, no picture is given. They do tell you guys something about an angle, so I'm going to draw the angle, GLD. And A is on the interior. Interior is inside, so imagine if you had like that was the door, and the door hinge, and it's open. D is inside. Sorry, A is inside. I wrote the wrong letter. A is inside somewhere, that angle. And usually what happens is that you, when it's in the interior, you have a ray that comes out and intersects that point. Okay, so if you look at that picture, what do you think your conclusion might be on that picture? That's all you're given. You're not given anything else. Go ahead.
Angle GLA plus angle ALD equals angle GLD.
Yep, perfect. measure of angle GLD. And what is the reason for that?
Angle add postulate.
Perfect, angle addition postulate. So we have plenty of time left.